This video is all about direct variation, and we're going to pick it up where we left off on the Google site. So on the Google site, we were discussing a girl named Maddie. She works at Chick-fil-A. She gets paid $12 per hour. So if we consider this scenario, let's answer these questions, and we are going to construct a statement of variation. So first of all, what's the independent variable? So if Maddie works at Chick-fil-A for $12 per hour, the independent variable is the number of hours. And we've talked before about how almost always time is the independent variable. What's dependent here? Well, what's dependent is the amount of money that Maddie will be paid. But there is a constant in this scenario, and the constant is $12. Maddie is going to get paid $12 for every hour that she works. So the constant in this scenario is $12 per hour. So we're going to make a table here. So our independent variable is hours. Our dependent variable is the paycheck. So amount of money she'll get paid. That's the dependent. So I said that we were going to write a statement of variation. So let's do that now. So the amount of money, we'll call it A, and we're going to think of this as a function because it is a function. The amount of money she gets paid will be in terms of the hours that she works. So A of H equals 12 times the number of hours. So think about it. If Maddie works 0 hours, Maddie gets paid 12 times 0, $0. If she works 1 hour, she gets paid $12. If she works 5 hours, 12 times 5, 60. If she works 6.5 hours, because this will be a continuous function. It's not going to be discrete here because time is fluid and it is continuous. So therefore, we can plug in for our domain, we can plug in decimals and fractions. So if Maddie works 6.5 hours, well, 6 times 12 is 72 plus a half is 6. So that would be $78. If she works 10 hours, 120, and so forth. So we'll just go for it. If she worked full-time 40 hours for the week, she would make $480. So this is a direct variation. The amount of money that Maddie gets paid varies directly to the number of hours that she works. As the hours go up, the amount of money goes up. And this is our statement of variation here. Now, one thing that you do need to keep in mind is that every single direct variation will have 0, 0 as a point that can be graphed. A direct variation always passes through the origin. A direct variation always passes through the origin. So here we go again. Here's our statement, this time just in terms of Y and X. So Maddie's pay varies directly with the number of hours she works. So pay is, of course, the dependent variable, Y. The independent variable is the number of hours. And once again, 12 is the constant of variation. And in a direct variation, normally we say the constant of variation is represented by lowercase k. Not sure why it's lowercase k, but that's what it always is. So here are the things to keep in mind one more time. In a direct variation, if the number of hours goes up, the pay goes up. If the number of hours go down, the pay goes down. One influences the other directly. So this, again, is a statement of variation. So On the next problem we're going to see, it's a little bit different. And let me cover up the bottom here so it's not overwhelming. So here you go. Your distance from lightning varies directly with the time it takes you to hear the thunder. So thunder is actually the noise that lightning makes, but you see the lightning more quickly than you hear the thunder because light travels faster than sound. So if you hear thunder 10 seconds after you see lightning, you are about 2 miles from the lightning. Now I've got the connected information color coordinated here. Distance is orange, time is green. So what we're going to do is we're going to take this first bullet point and we are going to write a statement of variation. We are going to do that right down here. So that's first thing. First, write a statement of variation based on what's given. Your distance varies directly with the time. So distance varies directly with the time. We don't know the constant of variation yet. That's why we're going to call it K. We're going to find it in part 2 here. So substitute in the given information. So now let's go to this second bullet point. If you hear thunder 10 seconds after you see lightning, you are about 2 miles from the lightning. So once again, the time is in green. The distance is underlined with orange. So we're going to substitute in the given information from the second bullet point. So what's our distance? Our distance is orange. It's 2. 2 equals K times T. T is time. Time is 10 seconds. So after we first wrote our statement of variation, now we're going to substitute in the given information and we are going to be able to solve for K. So 2 equals K times 10. In order to solve for K, we need to use an inverse operation and divide both sides by 10. 10s cancel. We find that K equals 2 over 10, which reduces to 1/5. So our constant of variation is 1/5. Third, rewrite the statement using the constant K. So if our K is 1/5, then D equals 1/5 times T. Remember, I gave you the constant of variation in the problem about Maddie working in Chick-fil-A. So we didn't need to find it in that one, but the constant here, the part of the problem that never changed, was the fact that Maddie gets paid $12 per hour. Well, in this particular problem, we had to use the given information in order to find the K value being 1/5. So now we've got our new and improved statement of variation. D equals 1/5 T. So now let's answer this question. About how many seconds would it take for the thunder to travel a distance of 5 miles? So once again, how many seconds? That's time. Time is underlined in green, just like it was on the previous problem. Our distance, underlined in orange, is 5. So we're once again going to substitute in given information. So how many seconds? We do not know the time. Time will stay T. The constant of variation, of course our constant of variation right there, it's 1/5. We just solved for it. Distance of 5. So all I was able to do was substitute in 5 miles for the distance. But this creates an equation that can easily be solved. So 5 equals 1/5 times T. If we want to solve for T, we're going to multiply both sides by 5. 5 and 1/5 cancel. 5 times 5 is 25. So about how many seconds would it take for the thunder to travel a distance of 5 miles? it would take about 25 seconds for the sound to travel 5 miles. That is direct variation.